Okay, so we're going to start from the beginning. So we have already covered this in our, theory class, I think. So familiar with MD8086 microprocessor kit, which is architecture, and also MO8086. So MD8086 microprocessor kit, you can, okay, right now we cannot show you because it is in the lab, but you can search in Google and you can see the picture, how it looks like. So MD8086 uh, microprocessor kit. Okay, so and we have cable RS232C cable. So okay, if you want to see this how it looks like, you can just copy it and you can go to, yeah, you can go to, yes, hello.
Assalamualaikum, sir.
Okay, so you can go to Google and write this MD8086 microprocessor kit and look. So we are talking about this one. Okay, we are talking about this kit. So this is available in Google, and there are lots of online documentation. You can still study it. Okay, there are lots of documentation. So how can you study this from the online? You have to just what you have to do. You have to just click on a link, any link, suppose this link, and then you have to click this link, right? Yeah, it's easy, and then you can study this. Very it's coming, it's coming. Where is the figure? Okay, it's loading. So figure is loading. So this is the figure, and these are the description, and this is the MD8086 microprocessor kit. Okay, this documentation is not that much good. What about this one? Oh, it's okay. So yeah, you can read this documentation. It is it is like a mini computer. It is like a mini computer. Okay, it is like a mini computer. So it is available in our lab. Okay, here is another documentation. Here is another documentation. Okay, so this is available in our lab, but right now cannot show you. So you can always check in online about this. Okay, and you can learn from there. Okay, so we're talking about this MD8086 microprocessor kit. Okay, then we have RS. This is the cable, so you can check that. This cable is to connect the processor with the computer, and we have IBM PC, so you can also check that. So how the IBM PC looks like. Okay, so let's check this cable. So how this cable looks like. Microprocessor kit. Okay, what is happening? Again, it's coming the same thing. It's not copied. Okay. So let's copy it again. Yeah. Okay, then you can see the cable, right? RS232. Which one is RS232? RS232. Yeah, RS232C cable. Okay, so this one is RS232C cable. Okay, so this cable is to, connect your, uh, connect your MD8086 kit, the kit we have shown, the first one, MD8086 kit with the computer. Okay, to connect your cable. Okay, let's check. Oh, its price is given. Okay, what is okay? Not about they are selling this on that side. They have given the price. And this one, check this one, check this one. This looks good. Oh, actually, they're selling it. That's why. Okay, so this is the cable. Okay, so you can look at here. So this is for connection from computer to your kit. Okay. One side it has 25 pin, other side it has 9 pins. So 9 pin, 25. Okay, so you can go back and you can check it. Okay. So this cable is just to connect that kit with the, I mean, the IBM computer. Okay. So this is the kit we were talking about. So you got kit, you got cable, and then IBM PC. What is IBM PC? Oh, it's not copied. Why? IBM PC.
স্যার আমাদেরকে ল্যাব ম্যানুয়াল কি দেয়া হয়েছে
Yeah, I have given you the manual, right?
মেইলে স্যার নাকি হচ্ছে গ্রুপে?
In group, I've given you the manual. So this PC is the IBM PC. They made this PC. This is the old PC actually. This is the IBM PC. So we have one copy of this in our lab, I think. Yeah. This is the outlook of IBM PC. Yes, this is the monitor, I think. This is the CPU. So we have the CPU. And this is keyboard. You can see there. Okay. Yeah, so this is the monitor, and below monitor, that is the CPU, I think. Yeah. And just keyboard also. Okay, then IBM PC, then have a C card or a C card. Oops. It's not copied. What is happening? Why it's not copied? Okay, so that is how to put some connection. Look, you have cord here, AC cable placement, power cord. So you can look at here, 3 pin. For selling, I think. Yeah, they are selling the product, so that's why they have given that. Okay. Whatever. Okay, so let's talk about this one. Okay, so these are the instrument we'll see in lab. Then theory, so MD8086 kit is a high performance 64 kb monitor program, and it is designed for easy function. After power is on, monitor program begins to work. In addition to all key function, the monitor has a memory checking routine. The following is a simple description of key function. So if you look at here, There are two types of key in this keyboard. One is called, that is the MD8086 keyboard, okay? Where can you look at this? You can look at this here. So let me show you. So this is the AC cord. Yeah, these are the AC cord. And this is the IBM PC. Then go back from IBM PC. Then this is the RS232C cable. And okay, so and this is the Microsoft circuit. So if you have this board, you are go to your, I mean, all program you can perform in your home. So we have a keyboard here. If you can look at here closely, that is keyboard we are talking about right now. Okay, this keyboard. Okay. So this keyboard, there are two types of key. One is called functional key, other is called data key. Okay, so there are two types of key: functional key and data key. So data key is for giving input. So can you see what kind of number is this? What kind of number? How many numbers you have? 4, 4, 4, 4.
15. Sir.
Sir,
Not
those
15.
are numerical numbers.
Yeah, what
16.
what are the types of number is this? We have 60 numbers here.
Hexadecimal, sir.
Right. These are the hexadecimal numbers.
Yes, sir, hexadecimal.
Hexadecimal number. Okay. So and that means we are giving input in this key in hexadecimal. Well, and there are functional keys. This is the reset key. If you make mistake, you can press this reset key. And we have other key like go, plus, minus, colon, HTTP, reg, GAAD, and mon. So all are written here. What is the function of this key? Res for system reset, AD for set memory address, and DA for update segment and offset and input data to memory. Okay, it may seem kind of odd. What do we mean by segment update, segment offset? We'll study this in our theories. So what is segment offset? It will be clear with time, no problem. So you have to update segment offset by this TA key and input data to memory. And this is colon for offset, and plus segment and offset plus 1 increment, register display increment. Minus segment and offset minus 1 increment, register display decrement. Minus 1 increment means decrement. Okay. And STP
Sir,
executes. Yes.
স্যার এটা কি হচ্ছে একটু আগে যে কম্পিউটারগুলো দেখাইছিলেন ওগুলোর কিবোর্ড?
Yeah, the keyboard of this kit. I mean this kit. Look at this. Now you can see this kit. Look at this white keyboard here. Yeah, this one is available in lab. Yeah, you can also buy this if you want. So its price maybe 30 to 40. Okay.
স্যার এগুলোর কাজ কি মূলত? এগুলো কি স্পেশাল কম্পিউটার?
Yeah, this is a kit where you can. If you look at here, this is the what? This is the dot matrix. It is for, I think, educational purpose to check how dot matrix work, and it has 7-segment display. Can you see here 7-segment display?
Yes, sir.
Sir.
Yeah, you can just I mean write some number in dot matrix. I mean there are LED, so you can blow those LED and you can check that and what is you are, I mean, printing here. Or you can write 7-segment display. You can display 1, 2, 0, 1, 2, 3, 4 by glowing the LED. Okay, that is for, I mean, university use this kind of thing. I mean, this kit for educational purpose. This is not for, I mean, commercial purpose. It is only for educational purpose. Okay, so we have HTTP and Go. Okay, HTTP execute user program, a single step programming. That means a single step. To perform a single step, you have to press HTTP. And go to user program to execute monitor function, and mon immediately breaks user program and non must double interrupt. And res means register display. Okay, these are the keyboard. And there are two types of key here. One is called functional key and other is called data key. You can read it from here. Okay, now let's talk about this microprocessor here a little bit more. What is microprocessor? So if you look at here, we have a processor here. You cannot see maybe because it's so small. Yeah, so small. So we have a processor here that is 8086. You can see there are many ICs here. So we have a IC 8086 here, and that is actually performing the controlling, maintaining the whole operation. So let's talk about this microprocessor. So microprocessor is a processor on a single integrated chip. We have already covered this in our theory, I think. It is general purpose processing unit designed to execute very large and complex problems. The speed of computer depends on the speed of processor. So if you use 16-bit processor, you get less speed. If you use 32-bit processor, you get more speed and so on. It is one kind of silicon chip. So it is made up of silicon. You already know that, which is made by VLSI, very large scale integration technology, right? You already know this thing. Function of processor provides timing and control signal for all parts, exchange data or instruction from memory and input-output devices, execute arithmetic and logical operation, decode the instruction, combine input-output operation with different portion, respond to various types of control signal and also read-write signal. Also respond reset interrupt, which comes from the input-output devices. So organization of processor, the organization of microprocessor consists of actually it is mainly two components, so arithmetic and logic unit, and and okay, so it actually composed of two units. You already know what are those two units. Can you say those? Yeah, anybody? Execution unit and bus interface unit, right? And this unit are within that, so we have to update this a little bit. Okay, no problem. So it is okay. So arithmetic logic unit, the purpose of ALU is to perform mathematical operations such as addition, subtraction, multiplication, division. You already know this. Additionally, ALU process basic logical operation like add or operation, also known the arithmetic logic unit, arithmetic and logic unit ALU, which serves the computational hub of the central processing unit CPU for the computer system. The control unit. A control unit can be described as a sort of circuitry that supervises and controls the path of information that runs over the processor and organizes the various activities of those units lie inside it. It carries out many tasks such as decoding, fetching, handling, executing, and finally storing the results. Control the execution of instruction in a sequential order, guide the flow of data through the different path of the computer. It also interrupts the instruction, and control unit regulates the time control of the processor and sends and receives control signal from various peripheral devices. Okay, I think you already know this. Then register unit. So registers are used to quickly accept, store, and transfer data and instructions that are being used immediately by the CPU, central processing unit. There are various types of register. Those are used for various purposes. Among the some mostly used registers named AC or accumulator, data register DR, AR, address register, program counter PC, memory data register MDR, and index register, memory buffer registers. Okay, so we'll read about this more about these registers in details in our class. Okay, last class we talked about, micro this architecture. We discussed something about this architecture. There are two units you can see here: bus interface unit and these are the execution unit. So in bus interface unit, you can see a summary here. The task of this summary is to convert logical address to physical address. We already said that I think in our class. So logical address, 16-bit logical address to 20-bit physical address. So that is what you can use this one to convert logical to physical address. And you can see there are a bunch of registers. These are address registers: CS, DS, SS, CS, and DS and IP. These address registers store the addresses of the data. And you can see, so when memory, if you connect memory with the uh, I mean this processor, then from that memory interface you can data will go here. So and you can store data here. That is called instruction queue. 1 2 3 4 5 6. So 6 byte of instruction are stored here, and from there you can transmit those instructions in uh, arithmetic and logic unit, ALU. So arithmetic and logic unit are basically in between execution unit, and this unit perform the operation, and after performing the operation it can transmit the output here in registers A, C, A, C, A, C, A. These are the data registers, and they can keep the value, what is the result, so they can store the result here. Okay. Okay, so if you look at here, it is written the internal architecture of AGS is divided into two functional units, bus interface unit and execution unit. Okay, so if you look at the task of bus interface unit, we already started this face or take the instruction or data from the memory. So bus interface unit face means bring. Okay, yeah, it can bring data and it can write data to the memory. It can write data to the port, and it can read data from the port. Port means input output ports or input device output device. Then BIU has three functional units: instruction pointer, IPH segment registers, and instruction queue and instruction pointer. Okay, let's talk about instruction pointer. It is a register. It is a 16-bit register that keeps the addresses of the memory location coming instruction to the location of coming instruction to the segment register. Memory space 1 megabyte of 8086 is segmented and divided into 4 blocks. Okay. Okay, there is a slight mistake here. That should be yes. Okay, just correct it. It should be yes. If you have sheet with you, just make correct it. It should be. I think it's the printing mistake. Okay. So the memory space of 1 megabyte, we already said that, and I think we show you the calculation how we can. I show you the calculation how we can find the 1 megabyte of space inside the memory of 8086. It's segmented or divided into 4 blocks. So this memory is divided into 4 blocks. Each block specified by the register with a maximum size of 64 KB. Okay, in each block contains 64 KB, maximum 64 KB. So there are 4 blocks. The registers are code segment, data segment, stack segment, and extra segment. These are the 4 segment registers. Now let's come to the instruction queue. It's perform the operation in parallel with the execution unit. If instruction queue faces instruction byte while execution unit is executing the operation. Okay, that's why it said it's parallel. It's working in parallel. So when execution unit executes some instruction, instruction queue faces the instruction and keep it in the instruction queue. The previous instruction is saved in group here, high-speed registers. Okay, so we have high-speed registers here, and 6 bytes of instruction are stored here. Okay. Now let's come to the execution unit. We talked about bus interface unit in short. Now execution unit. The execution unit decodes instruction, execute the instruction, you contains the control circuitry to perform various internal operations. Execution unit divided into 5 functional units: general purpose register, pointer and index registers, ALU, arithmetic, flag register, timing, and pointer. Now, what are the general purpose registers? There are 4 general purpose registers: X, DX, CX, TX. These are the 4 general purpose. 8086 micro consists of 4 general purpose registers, and each register is 16-bit. Okay, it has 4 general purpose registers, and each register is 16-bit. So in total, we have 4 general purpose registers. X is the accumulator register. It is of 16-bit and divided into 2 8-bit registers, A's and L, to also perform 8-bit instruction. X is generally used for arithmetic and logical operation, logical instruction, but in 8086 microprocessor. BX, it is the base register. It is of 16-bit and is divided into 2 8-bit registers. BX and BL to perform 8-bit instruction. CX is used to store the value of the offset. And we have CX, then it is a it is the counter register. It is of 16-bit and is divided into two 8-bit registers, CX and CL, and also perform 8-bit instruction because you can access the 8-bit registers CX and CL. That's why it can also perform 8-bit instruction. It is used in looping and rotation. DX, this is the data register, is of 16-bit and is divided into two 8-bit registers, DX and DL, to perform 8-bit of instruction. DX is used in multiplication operation and input-output port addressing. Okay, so if you look at here, you can see these four general purpose registers. These four are called general purpose registers: X, BX, CX, DX, and they can be divided at 8-bit, H and L, DH and DL, CH and CL, DX and DL. These are the 8-bit. Okay, and SP, BP, SI, DI. Okay, pointer and index register. Pointer A0X has two pointer register, that is called stack pointer and base pointer. It has two index register. You can see here source index SI and destination index DI. These two are index registers. Okay, so up to this we have covered. So who can say how many? Okay, I should ask some questions. Shaun Ali, Mr. Shaun.
Yes, sir.
Yeah, how many general purpose registers 8086 has?
Sir,
How many general purpose registers are there?
eight registers, sir.
Okay. Not 8. There are 4 general purpose registers. Well, we already said X, BX, X, DX.
Yes, sir.
Okay, ALU. ALU means arithmetic and logic units. It is 16-bit. ALU performs. Okay, it is bit is missing here. You just write bit. 16-bit. Right here bit. So 16-bit. 16-bit ALU perform arithmetic and logical operation with 8-bit as well as 16. It can perform 8-bit operation. Also, it can perform 16-bit operation. Flag register. 8086 processor is microprocessor has 16-bit. Okay, has is missing just right. Has 8086 microprocessor has 16-bit flag registers. Here 9 flag are used, and 6 flags are unused. Okay, out of 16. Okay, 9 flag we use and 6 flag are unused. Among this 9 flag, we divide it into two categories: status flag and control flag. So 6 status flag, carry flag, 0 flag, sign flag, priority flag, and overflow flag. And 3 control flag, direction flag, interrupt flag, and trap flag. These are called control flag. So we'll study this flag register in more details in our theory class. Then timing and controlling it. It controls all internal operation and also responsible for generation of control signal. Okay, about microprocessor bus system, about a computer buses. Okay, what is computer buses? In computing, a bus is defined a set of physical connection cable, printed circuit, which can be shared by multiple hardware components in order to communicate with one another. There are 3 types of computer buses: address bus. I think we already discussed this: address bus, data bus, and control bus. Those are called system bus, right? We already talked about this. The first is the address bus, okay, sometimes called the memory bus, which transport memory addresses to the processor, to that the processor wants to access in order to read and write data. It is a unidirectional bus, and that is from processor to the peripheral. The direction is from the processor to the peripheral. We already said that in our theory class. The second is the data bus, which transfer instruction coming from and going to the processor. It is a bidirectional bus. The third one is the control bus or command bus, which transport order and synchronization signal coming from the control unit and traveling to all other hardware components. It is a bidirectional bus. It is also transmit response signal from the hardware, like read and write timing signal. So if you can look at here, this is the processor, this is the keyboard input controller, this is the output, or video, visual display unit, like monitor. Monitor is called video, that is the visual display unit, and input, output, and memory. So there are three buses, how they are connected. So you can see uh, address bus from processor, it's going to the address. So that means processor sends address. And if you look at control bus, so you can see it can send and receive data. That is, I mean, two-way communication. Similarly, data bus, you can put data inside processor, you can keep data out, put data outside processor. If you look at here, so output device, you can send control signal from processor to a peripheral or peripheral to processor. And from data bus, so you can send data output. So output means you are giving data from processor to the peripheral, or input means you are taking data from the processor to the peripheral. From peripheral to the processor. Okay, so main thing is this is the unidirectional and these two are bidirectional. Oh, we have already covered the architecture of 8086 microprocessor. What is the architecture? And at the beginning, we have four instruments here: MD8086 microprocessor kit, RS-232C cable, IBM PC AC cord. These are the four instruments need to perform the operation. Then after that, execution unit. Yeah, so this is the okay. Just read this. Okay, it will make sense. It is written very easygoing way, so it will make sense definitely. You just read this. Okay, so after that, okay, so this is the bus. Okay, so EMU software. Now let's come to the software because it is our main. I mean, we are going to depend mainly on this software. Okay, because we cannot go to the lab right now. Okay, so MU8086 software. So this is the microprocessor emulator with an integrated MU8086 assembler. The emulator can run program on a virtual machine and emulate real hardware, including screen, memory, and input-output devices. It helps your program in assembly language. It helps your program. Okay. Okay, it's a you can write the program in assembly language. The source code is compiled by the assembler and then executed on emulator step by step, allowing you to watch, register, flag, and memory while your program runs. Okay, did you download this one? MO806. How many of you download?
Yes, sir. Download.
Yes,
Installed?
sir. Download.
Yes, sir.
Yes, sir.
Download,
Install
sir.
it,
Yes,
sir.
sir.
Installed on the PC, sir.
Very good. And you can run. We have many program here. You can run this program here. Look at here. Second program. This is the second program. So you can see lots of program there. Second, third, all program. Look, third program, fourth program. You can run this. Then fifth, sixth. So we have many program here. You can run those in emulator one by one. So those who have not yet download this software, okay, let me show you how you can download this. Okay, so first you have to go to here in Google, and here you write EMU 8086. Download. Okay, I think this is the first one. It is the no. Yeah, we can see a Jeep here. I think this is this one. What do you think? Okay. What about second one? What is there?
Sir, I give a Google Drive link on the messenger.
Oh, okay, that's good. That's good. Okay, then you can also download from Google Drive. A link is given there, so you can download. What about here? Is the link here? Oh, we can see a zip file here. Okay, let's check what is there. Okay, look, it's very small. It's very small. You can download this very easily. So it's very small actually. Okay, where is it? Okay, just extract it. Change, shipping. Okay, let's see. Oh, you can see it here. Look, it is extracted and you can click it. Oh, it's not that one, I think. Is it that one? Same one? No. Okay, I already, I think installed it. Okay, let me show you the install version. Where is it? Here. Okay, can you see my screen here? No?
Yes, sir.
Okay, you can see. Okay, that is what I have installed here. So what you have to do, you have to go to here, second, experiment number second, number two here. Yeah, this is the number two. Okay. Okay, the result is not given here, so you have to mess with the result. Okay, let me check whether I have result or not. Uh, where is the result? Lab minimal, question, computer. Okay. Okay, I will provide you a sheet that means results. So how can you mess with the results? So this is the code actually given here. Okay, look, there are three, there are two types of code here actually. First one is the address. Okay, forget about that. And the second one is the machine code. That is to, I mean, to you can perform this machine code in lab. Those are machine code. So you have to perform those in device, not in software. Because machine code you cannot write those in software. You can write assembly code in software. So this one you can perform in software. These are the assembly code. Okay, so you can see here there are three types of code. Okay, first one is the address, that is not code. First one, forget about first one. So first column is the address, and the second column is the machine code. So you want to perform the machine code in your lab, okay? And third one is the okay assembly code. So we perform the third one in our emulator. And the last one is the comment. So there are four columns. You can see what is the class copies of the column. Okay, so this is okay. This is the code. How can you? Okay, you should not copy this. You should write this one by one. Okay. 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 The problem is how can you have to write this. Okay, so if you run this, it will show you the because you have machine code, you have address, you have to eliminate those, and this is the comment here. You can comment. So comment before comment, you can put semicolon. That is what you can do.
Sir, open this PDF with browser, sir. You can copy that, sir, section, sir.
Yeah. What do you say?
Sir, I saying that, sir, open this PDF with sir browser, sir. Then you
Okay.
can copy that section, sir.
Okay, then you can run this one. Please share your screen. Actually, it's better. So I will ask you one. I mean, some of you one by one, each and every class, to run this code. Okay. Actually, output is not given, so I will give you the output to match whether your output will matches with your result. And to understand the code, so please Google it and try to understand each and every time from there. So it will be better. Okay, so you can do.
Sir.
Yeah, you can share your screen and you can do this.
No, sir. So according to you, sir, do you need to memorize that course? Otherwise, how can we write that?
You check, you'll see, and you write. By checking at this. I mean, you check the lab manual, and then from there you can write. Okay.
Okay, so sir, our main purpose is to run the program and show you the result, right?
Yeah, you run. You have to understand what is going on there. Otherwise, what is the? I mean, what is the how you are getting the result? That is what you understand, right?
Yes, sir.
Why you are getting this result? Why you are getting this result? So it will. If you don't understand, then what is the purpose? Of, so understanding is the main purpose. So to understand, you have to Google it. If you don't
Okay,
understand something, okay. Otherwise, anybody can run because code is given there. You can
Sir,
run
I'm
this.
sharing my screen, sir.
Yeah, we can see. We can see. So you can run.
Sir,
Uh,
machine code, sir.
no, not machine code. You can. What I said so far. You machine code you cannot run in emulator.
Sir,
That is
sorry.
what you have to run in. I mean lab. You can run in assembly here. Okay, third column, and you can
Sir,
write comment if you want.
sir, this one, sir.
Oh, one by one comment. That is what I can also do there. I mean, we have to. I mean, copy all together.
Sir, also the comment, sir.
Yeah. It's better to write. You can write it. It's. I mean, writing. If you write it, you will understand more. Also, it's easier than copying, I think. And before comment, put a semicolon. That is the rules of assembly. When you start a comment, you just put a semicolon.
Sir, it is open after comment.
Before comment, yes. It looks odd. You just put semicolon with the, I mean, word with the word before immediately before the word. It will look better.
Before I, sir.
Yeah, before I. And you can remove left space. You can remove left space. We don't need left space. Remove it. Not that space. I said this space. Move space.
Sir, after move, sir.
No, before move.
Okay, sir.
Left
I
side.
understand. Okay.
Yeah, now it's good. And put a semicolon before I. Okay.
Sir, after that, sir.
You have to write one by one all the commands. Okay, I have to share you the answers. I think answer manually. Otherwise, you will not understand whether you are right result or wrong result.
So what will be the problem, sir, if we copy it from there, from the table?
What? Hello? Say.
Sir, isn't it tough to memorize the code? I mean, sir, suppose add, we have to write this thing. Is there any easiest?
I cannot listen in properly.
Asif, you missed a code.
Which one?
Which one?
The one you just written.
I reread this code.
Yeah. No, okay.
Sir, can you listen me?
Yes, now I can listen in.
Okay, sir, I'm just talking about, sir, how can we memorize the all code here? Isn't it tough to memorize? Is there any easiest way?
No, you don't need to memorize this. I mean, these are not for memorization because these are the code. You can write any code. So these are not like you must have to memorize. So this code, like, you can change those if you want. So there are. So what you have to memorize here is the opcode. So what is ADD means, what is ADC means, and what is SCV means, what is SBB means, what is MOV means. So S is what that means, and C CBW, CWD, DEC, INC. This kind of code you have to keep in mind, and what is the purpose of those code. Okay, otherwise, the number you don't have to memorize because you can change to other number also. Okay.
Okay, sir.
474789. So just put ace all those number after giving all those number. Just put ace. Those are the hex number. All are the number hex number. So there is there are some mistakes here. So actually, we
Where, sir?
forgot. Yeah, those number we forgot to put. H. After
That
all number.
numbers have no.
After
Yes,
After all number you have to put H. H means hex.
sir, so after sir,
Each and every number you put.
sir,
Yeah.
the 4789H.
Yes. Those are the hex numbers.
What about the first number, sir? After 0, isn't there will be a H?
0 is always 0. It doesn't matter, right? You know that.
Okay, sir.
Okay, so you can run up to this, I think.
Okay, sir.
Emulate.
Which button, sir? Emulate, sir.
Yes.
Sir, there are errors.
Okay, I think they made some mistake there.
Sir, in this
You
line.
didn't written the whole.
Just yeah.
Sure.
You choose the value there.
Sir, it is number 2,
Sir,
sir.
both are class 101, sir.
Choose the
MOV.
letter.
Not SHS,
No,
sir.
yeah. You choose the letter, I think.
Store H into flag.
Sir, first line, sir.
Yeah, you
It
choose
is
the letter. Can I see? You choose the letter, I think.
illegal extraction, wrong perimeters, MOV.
What do you, what do you have written there? I mean, it's small, I cannot see.
Sir, in the second line, sir.
Second line, yes. What do you have
Sir,
written there?
it is first one is SHAF, then sir semicolon. Comment is store AH into flag.
Oh, it is written in wrong way. I mean, in the sheet also. SHAF. It should be SHAF. Okay.
SHAF, sir.
Yes, yes.
Sir,
Okay. Actually, I did not get time to, I mean, check that before actually.
then sir,
Yeah, SHAF. It should be SHAF. SAHF.
oh SAHF.
Yeah. AH. Register AH. SAHF.
Yes, sir.
Okay.
Now it
So,
is blue.
yeah. Ashok has written this one from the sheet.
There are
Some
errors
mistake.
in number 11, MOV.
Number 11. Okay, number 11. So when you, okay, there are some assembly rules. Okay, when you write, what is
Also
number
number
11?
one, sir.
What is
Sir,
written in
number
number
11 is
11?
MOVAL, comma FFH.
Okay, there is some assembly rules that when you are working with FF, you have to put a 0 before F. That is the rules of assembly.
Yes, sir. Yes, sir. 0.
0, I mean, 0 has no meaning, but it is the rules. It is the rules that I have.
Okay, sir. Sir, now it is seems okay, sir.
And now it's running. Okay, so this is a single step programming. That means you can run one by one step, and you can check the out. So you already know that. Okay, where is it? Okay, and where is the other window? Why did you minimize it? You run it again.
Sir, it is all
Yes.
automatically minimized, sir. I don't know,
Okay.
sir, why.
Okay, so this one. You can check it here. You already know that when you give the command in I mean 8086 processor, then it has ALU perform the operation. After performing the operation, result will store in register. If you look at the left side, you have data register X, DX.
Yes, sir. AX, BX, CX, DX.
Yeah, so your result will be stored there when you
Yes, sir.
perform the operation. Now, when you perform the first step, move X to 0. So you have to know what is this command will perform. So just try to understand those what is this command will perform. If you don't understand, you can check the book always. There is book, and also you can Google it. That is easier. Just write it one line in the Google, and you just read what this command actually performs. So it is very easy actually. The first line will perform the move X to 0. So the value of register X will become 0. So that means the top corner, the value will be 0. So if you give single step, just put single step and see what will the value of X. So you can see single step there. New, yeah, single step.
Sir, what can I do now, sir?
Left side, in left side, there is a single step button in left side.
Single step button, sir. Yes, sir. Single step.
Just click that. Okay, then if you look at the register X, the value of X is 0000. Can you see that data register?
Data register value is 00. Sir, after clicking single step, it's on the, sir, now CX, sir.
Yeah, it should be register value is 000. Okay, so actually, yeah, please go through this. I mean, okay, please go through the each and every code from the Google and write down what this code will perform. Okay, that will be better, I think. Then
First line, sir. First line, sir.
Yeah, each and every line. So it is your task, homework. So
Okay,
each
sir.
and every line, please write down what this code will perform. So if you go through each and every line from the Google, and please write down what this code will perform. After that, we will run this code. You will understand more. Yeah, please don't write comment when you are searching.
Okay, sir.
Please don't write comment without comment. So we're going to Stack Overflow. Stack Overflow is a good site. If you have any problem related with programming, so you can
Sir, here
always.
I found something on Stack Overflow.
Yeah, so you can read those related things and you try to understand what is the difference between EX0 and move EX. Okay, that is another question. EX is a 32-bit register that is not available for our emulator, and AX is a 16-bit register. That is the difference. That is another thing. But the thing is, what is you have to know what is the move X, 0. That is simple. That's why people I think and they are not answer.
Sir, I think 2 minutes remaining, sir, in the class, sir.
Okay, so please go through this code, second code, and then the next class will run this. Okay, and see the result.
Okay, sir. Okay, sir.
Go through this each and every line and let's see. It's the previous slide.